Hello, everybody. So what was requested was a video dealing with the quadratic formula, how to plug things in and such. So the problem with the quadratic formula is sometimes we get different answers at the end. For example, we can just get one answer like x equals 5. You can get two answers like two integers, like let's say -2, or x could be 5, 3 or something like that. You could also get more complex answers such as this. So you could say like -4 plus or minus the square root of 13. And sometimes that's even over another number like that. So we kind of have to see what we have as we go along. So I'm just going to make up an example here. So let's say we have an equation like this and we want to solve it. Now, first of all, you have to have 0 in there. So if this equation looked like something else, you have to manipulate it to get the 0. And then we want to identify what A, B, and C are. As you first start this, you want to kind of lay out A, B, and C. But as you get used to it, you kind of skip this step. Right? Signs are important. Notice the -6 there. So the full quadratic formula looks like this. A few things about words. We have quadratic equation. Now, the quadratic equation is just anything that has x squared and then y squared, things like that. So this right here is considered a quadratic equation. And the thing I'm going to write right now is a formula. So the quadratic formula is this. There's no way around memorizing this. Some people do a little song with "Pop Goes the Weasel" or something like that. But I'm going to skip that and assume that you know this. So the traditional way to plug in everything is with parentheses. So something like this, so -6 plus or minus, and B again is -6. So I'm going to say -6 squared minus 4, and then these two things in parentheses, 1 and 8. All over 2 times 1. And then we go ahead and simplify that. So -6 is +6. 6 squared is 36. And 4 times 1 times 8. You got to make sure you get the sign right there. So that's 32. So what I'm showing right now is basically all the steps, right? So the kind of thing you would do if you were teaching this to somebody for the first time. And as you get used to these, you want to skip some of these steps. Notice here that we don't have a square root anymore. In this case, you want to take this statement and solve both of these. So then this becomes 6 plus 2 over 2 and 6 minus 2 over 2. That's 8 over 2, which is 4. And 4 over 2, which is 2. So x equals both of these, and that is your final answer. So you want to circle that. That's everything. Now, so how do I do it, right? So -b, I worked that out in its first place. So I say, okay, that's 6 plus or minus -6 squared. That's 36. I do that right away. So this is more or less how I would figure this out. 2 times a, I also do that mentally. So that's just 2. For the next step, I usually figure out everything that's under the square root. So that's 36 minus 32. That's 4. And then you get to, something like that. So, it's up to you what steps you want to skip in the end or what the teacher's expectations are. That is, you also get integers for answers. If you ever get integers, that means it could have probably easily be factored. If you look at this statement, you probably could factor that and find your solution that way. And so I'm just going to move along, take screenshots of the video or whatever. Now I'm going to make up an example. Now, the fact that I'm making up an example will probably mean it's not going to work out so nicely with integers. Probably going to be some random numbers here. Now you take one look at something like this, it doesn't look like you could factor this at all. So you just jump right into the quadratic formula. So x equals -b, so that's -7 plus or minus. Okay, so I'm going to do it the second way that I showed, where I'm just going to skip some steps. So b squared is 49. Everything else I'm going to, put in there because it's relatively easy to make mistakes with this kind of thing. And here is 2 times a there. Okay. So to remark on the things I did mentally, I always do the negative b part mentally. Then I always do b squared mentally. And also the 2a part. Those 3 things. Okay, next you want to simplify what's under the square root. Yeah, some bigger numbers there, so I'm going to go ahead and use the calculator for that. Get negative 7 plus minus square root of 277 over negative 6. Okay, now you want to check 277 to see if it has any perfect square factors. So that's what we're asking. Does 277 have any perfect square factors? How do we check that? So there are many different ways. One, you could try to like a factor tree. You could also try like a list of perfect squares. So remember, the perfect squares are these. You multiply a number by itself, you get this whole list. If you're taking a test that has to do a lot with perfect squares and you're not too comfortable with it, it might be a good idea to like write this list on your test somewhere so you can constantly refer back to it. Now you want to go to generally like about 1/2 of 277. So about half of 277 would be like so like 130 something. So anything above like this number, wouldn't fit there. So you check, is 277 divisible by any of these things? I don't think it is, but you go through and check to make sure. So right now I'm taking 277, dividing it by various numbers that I think might be possible. Okay, just as I thought, this is not going to work, nothing like that. So we can't break apart 277. The last thing we should do though is fix like the negatives. So -7 over -6, that makes these positive. Now, if you flip this sign, it's still the same sign, it's plus or minus. So you just leave it like that. So in this case, this is actually 2 solutions, but you can express it as one thing. There we go, that's your final answer. Now for the next page, let's take a look at how to break down certain radical. So let's say I had like radical 180. How do you break that down? Well, you're going to use the list of perfect squares as well, and see if anything goes into 180. You could do 180 and then divide it by the various numbers, like say 180 divided by 49, because that's a perfect square. Now that, if I were to do that, I get something like decimal, so 6.7, blah, blah, blah. That means that this did not work. This could be time consuming. So another way you could do this is you could do prime factorization. Pick anything that goes into 180. We have that. There I see 9 and 10. Oh, 9, that's a perfect square there. Let's break it down further, see what happens. So 9 is 3 and 3. 10 is 2 and 5. Now, anywhere where you see a number appearing twice, that'll help you to build your perfect square. Here I see 2 2s and 2 3s. If you multiply all that together, you get a 36. That tells you that the 36 is the perfect square. You put that in front. 36 times what? Well, it'll be this last 5 here. And you take this square root of the perfect square and leave this other one. So this is how we would break apart 180. Let's try another random example, and I might have to look up some to make them work out a certain way. Let's consider this, like, what if you have an equation like this? So the first thing you have to do is to get 0 on the one side. There's a number of ways you could do that. I like to keep the x squared positive if possible. We have that, and then I'm going to identify a, b, and c. Again, this step you could do at the beginning and then gradually phase that out. So the quadratic formula again is this here. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So negative b, I figured that as 3. B squared, I'm going to square this 3 right away, 9. Notice this is always positive, that part. 4 times 2 times negative 14. 2 times a, I've also been doing that mentally, that's 4. Next step, you could figure out a few things. You could do this part if you want, or you could do everything all together. With the calculator, it's relatively easy to do all that together. That's not what I expected here. Okay, so it's you actually get 121 from there. It's a perfect square itself. I'm writing these randomly, so I don't know what to expect here. So we get this plus or minus, that's 11 over 4. As said in the first thing, when you get something like this, you figure out both solutions. So you figure out this one and this one. That's 14 over 4, that's 7/2. And yeah, negative 8 over 4, that is negative 2. Those are our two solutions. I'm going to take a pause for just a moment and look up a little bit of something.